Hi everyone, let's go ahead and get started with our lecture on text generation with HuggingFace. We will be using here text generation HuggingFace models to generate the text data. But before that, you need to know that how the text generation is done and what is text generation. So you can understand the text generation with this example where some context will be given, and based on that context your model will generate a further data. For example, if you have given this context to your model, like 5 plus 8 equal to the 13, 7 plus 2 equal to the 9, this is the sequence 1. So something like this, you can give a context to your model and then you can ask your model to generate further. Then your model would generate a sequence further. And then you can give your model another context, something like this, where spelling, this wrong spelling is getting corrected with correct spelling. Like goat, here goat is going to be corrected as goat, sekne is snake, breed is bird, and some psi or whatever you can call that got converted as fish, and then duck, and then here you have a chimp. So basically, this text generation model, a text generation tool, you can use for some fact learning task, or you can use it for spelling correction, or you can use this for translation as well. So something like here you see, you have given here a thanks, this got converted into a mercy, and then here you have hello, that got converted into bonjour. Okay, bonjour. So this is a French language here. Alright, so these are the context where you can use your text generation technique or text generation model to use in these techniques. So overall understanding is something like this. You have given some input here or some context, then you apply a text generation model, and then finally it generates here output. For example, you can use this text generation model in poem generation, in news article generation, or you can use this in story generation as well, or you can use this text generation model for code completion or code generation model as well, where you give some context and then it will generate a code for you. So here you have an output. Once upon a time this was context, then thereafter it has started filling other terms here, like we know that our ancestors were on verge of extinction, etc, etc, etc. Alright, so how these text data are generated? Now you see, this text data have here context first. So these are the context. Once upon a time, I'm gonna take here another example, like let's say you have given a context, transformers are the. Okay, this is the context you have given to your model, the first 3 words to your model. Now your model will predict the most probable next word. Now the probability and selecting these next words are based on various factors. There are various techniques which is used to select these most probable words. For example, here you can see these are the techniques. You can see greedy search technique, beam search, top K sampling, and top P or nucleus sampling. So here I'm showing you an example, like transformer are the, thereafter multiple choices are generated here from the set of dictionary. Then you select one out of these as the next word for your transformers. So once the next word is selected, then that is included as the context itself, like transformer are the most, and then it selects one of these choices, and then it add into your generated transformer text data. Thereafter this got added as the context itself, and then it selects here the next probable words and then add that into the sentence. That's how these transformer generates these text data, where these red are predicted tokens and these are input token. Iteratively it feeds these data to generate the next probable word. Alright, so this method is used, or this method is said as the greedy search method. If you select the word which have the highest probability in each of these rows. Now you see transformer are the, then the most is having here the highest probability. That means the transformer has predicted here, after the transformers are the input sentence, the most will be the best fit here. So you put here the most there. That means it is discarding these, although you can see there these are also a good choice. For example, you can say transformer are the only, you can say there transformer are the only, and then you pass there only, then these set will get changed thereafter. Alright, let's go ahead and see what are the challenges in generating coherent text data. So what's the coherent text data? Coherent text data is like you generate the text data that need to be in context for the previous data. If you are generating a large data set, then in that case your whole story need to be in context or in coherency. Otherwise what will happen here, some paragraph will be referring to some other context and some other paragraph will be referring to another context. So one challenge is there, it need to be coherent there, and for that coherency you need to avoid any kind of repetition. Sometimes transformer shows a tendency that it generates their repeated code multiple times, and if there are limited vocabulary for the transformers, then it will generate the data from only the set of vocabulary. One example you can see it here. If you select greedy search algorithm, in the greedy search algorithm you will be getting only these as the top choices no matter how many times you run your code. Another things you can see here, the lack of context. Now let's go ahead and see how you can generate these text data. So as I told you there, transformer have these features. You can select these features, any of these features, to generate your text data. It has their own pros and cons. For example, in greedy search, it will be selecting here the most highest probability or the most probable the choices every time. In this way, what will happen here, no matter how many times you run your code, it will keep generating just a single pattern of the data. There won't be any variation. So that's the greedy search. In beam search, what happens there, it starts generating the data and it doesn't select the first one, but in fact it selects there multiple words at a time or multiple choices or a token at a time, and also their probability, or you can say they are the loss functions. So here these numbers which you are seeing there, these are the blue numbers, that means these are kind of the loss there. So they select these loss there and then finally they append these together and then identify that which sentence have the lowest loss, then it will select that particular set of the tokens to generate the sentence. So in this what happens there, it selects, like let's say it starts with the he, and then it says that hit and the struck these two could be probable choices, and these number of the branches which you see here, these are known as the number of beams here. So you see here the 2 branch, that's mean there are 2 beam here. So he, hit and struck, these are the 2 context. Then for struck the loss is very low, and that means it's a minus, the loss is very high. In this case this will be discarded. There is another feature for the beam search. If loss is very high, then in that case it automatically discard that token. So this one is very high, then it will discard this one, and then it goes here, then it selects here and me, and then finally it goes again tart pi in with on 1 pi tart, all these stuffs it selects, and then finally it selects the one which are actually the best one. So this is the beam search decoding. There are 2 more decoding technique, the top K sampling and the top P sampling. So again, you see there the difference between greedy search and the beam search. In greedy search, you will always get the same set of the text data. In beam search, there is high probability that you will again get a same set of the data, although the data could be different than this greedy search. But if you run your algorithm multiple times in beam search, you will be getting a same set of the data. Because anyway, whatever the text data is generated here, it will be always having the lowest at the first time, second time, no matter how many iterations you run, because it selects every time the lowest probability sentences there. I mean, lowest loss sentences there. So it combines all the tokens together. It selects the lowest loss in the sentence where it has happened. It then select that sentence. So to avoid that or to overcome with that problem, there are two more methods here, that is known as top K and nucleus, or you can say the top P search decoding. In this, what happens here, you see there, once you have got these tokens here, only 5 tokens are represented here, but actually these tokens, you can say that the length of these tokens could be the total number of dictionary tokens there, because every token's probability is calculated there. So you can say that it is length of dictionary itself. So it's a huge length there for a choices. So there are two techniques. In these choices, either you select the top K, or let's say the top 50 or top 100 most probable tokens. Here example is top 5, but you can select the top 100 and then you do a random sampling. So you select randomly whatever the tokens, the best token comes, and then you take that as the context token and then you append that into your input text data. So it's like that. So in this way, in these two methods, in both of these two methods, you will get every time a different set of the text data if you generate your data there for top K and nucleus as well. So in the top K, you select there, let's say the top 100, then in that case, the top 100, it will every time, it will randomly sample of one token out of those most top 100 probable tokens. But what happens with the nucleus search decoding technique? In nucleus decoding technique, it selects the top P, where P is probability. Now I say that I want top 99 percentile. Alright, that means you want to select only those tokens which falls into top 10%. Alright, so let's see here. If you see here in the top 10%, in this there is no token. So this will be decoded as the percentile, then probably you will be getting out of, in these number of few tokens here. And then similarly, you say here the popular, powerful, common, famous. Again, if these are falling in top 10 percentile and top 10 probability is different. So the top 10 percentile means this will be considered as top 100 percentile. Alright, and the next one will be considered as after 100, whatever the range is there. So basically it is known as basically this one is known as normalized probability. So you divide this 4.96 divided by 8.53, you will get there probably a 50 percentile or something like that. So it's like that. So in top 10 percentile, you will be getting this one, this one, this one, and probably this one. So in this, it seems like in top 10 percentile, you will be getting all these. But if you select large number of percentile, or if you relax your percentile criteria, you will be getting there the random samples, a little bit more random samples than the top K. Now you can say that it is the same thing here, or it might be confusing to you. Let me again clear this concept to you. What happened if you do the top K? In top K, let's say let me tell you here. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Let's say it is the top 10. So in top 10, it selects these top 10 most probable tokens. And then it randomly samples these 10 tokens with the random generator, or you can say generate any random numbers between 1 to 10 and then select that token automatically. But in this case, what happens here? If your dictionary itself is very huge, let's say 1 million versus 1 billion dictionary. So in 1 million dictionary, you are having their top 10, and in 1 billion dictionary again, you are having the top 10. So in 1 billion dictionary, your top 10 is relatively lesser than the 1 million dictionary. But if you select it with the probability wise, then you say that you select all the tokens which have probability greater than, or probability percentile I am saying, probability percentile greater than 0.8, then in that case you will be always having a fair number of the samples in the top samples there. That's how it generates here. So you can understand this with here a person says that nice, are they doing that for a particular region? Beam search with beam width 10. Beam width 10 means there would be a 10 branches there. It says that yeah. But if you select here the top case sampling, here the temperature is also. So this temperature says that how it is going to sample these. High temperature means more randomness will be there. So it says that the top case sampling, yes, and they are typically on TV. Be happy to look at us. That's a good question. This is not much coherent because you see there yes and there are typically on TV. Now you see these particular are not meaning much. Alright, these particular sentence or phrases are not meaning much. But if you see nucleus sampling with the P is 95, that means the percentile is 95 here. So the top 5 percentile tokens will be selected. Yeah, did you know that 70 so was remade in UK? Alright, now let's go ahead and see which model we are going to use here. We are going to use here GPT2 model. You can see this GPT2 model at HuggingFace. At the HuggingFace, it has here, you can see there are multiple versions of the GPT2 model. One GPT2 base itself and other GPT2 models are GPT large, GPT medium and GPT XL. The XL. Alright. And this GPT2 model have here inference text data. Let's say I want to generate here once upon a time. This is context. Now it's going to generate here a story based on this once upon a time, and I'm not sure if it is coincidence or not. Probably it's not correct. The reason is it's the smallest model here. If you select GPT2 large, okay, so for GPT2 large seems like this inference API is not present, so probably we are not able to see that. But anyway, we will be using GPT2 model, and then I'll be showing you if you give here once upon a time, then you would be able to see their better output or a better result here. Alright, let's say I'm not sure, and thereafter if it generate text data, I'm not sure this is a good idea or not. I'm not sure if, probably it's not very good generator here because this is a smallest model of GPT-2. There are 5 ways, or you can say, this have a 5 step or 5 points in the GPT-2 architecture. This GPT-2 employs here self-attention mechanism, and GPT-2 harness the power of encoder and decoder for the transformers. It is not like other models like the BERT where it uses only encoder techniques. Then these GPT-2 models are pre-trained on massive corpus, a huge data set, and thereafter it uses these attention mechanism so that it can learn which words are important out of the context. Thereafter you can use the GPT-2 model to fine-tune, and you can adopt it on other classification tasks. I mean to say that other classification tasks, question answering, text generation or text completion tasks. And then you have here a text generation. Finally, you can use these initial prompt or context to generate the text data. Alright. Let's go ahead and get started with writing our code for the text generation. We need to first install our transformers. Along with that, here you need to also select here a GPU. Runtime, now you need to change your runtime as T4 GPU and then just save it. Alright, thereafter you are going to just run it. It's going to run, it will take a while, and then you just save some space. You can collapse that headers there. Alright. Transformer have been installed in our computer or in Google Colab. One more thing I would like to tell you here, we have seen here many techniques to generate text data. Out of these techniques, we are going to select here beam search decoding and nucleus search decoding. These are the two most famous techniques, so we'll be using these two techniques to generate our text data. Alright, so once transformer is installed, I'm gonna just comment that one so that I can save some space here. Thereafter, I'm gonna write here import torch, that's the PyTorch. Thereafter, I write here from transformers import auto tokenizer. Along with that, I'm gonna use here auto model for causal language inference. Alright, so what are these two things here? As we have seen in our previous videos, if you provide a checkpoint, model checkpoint, then it will automatically fetch a corresponding tokenizer from the internet or from HuggingFace, and similarly we are seeing here auto model for causal language model. So this particular model is used to generate text data. So I'm just gonna run it. Alright, so it will take a while to import torch and transformer. Everything is done here. Now we need to find out if there is a GPU available. Although we have GPU, but dynamically you can identify that CUDA device equal to the CUDA if torch dot CUDA dot is available, else CPU. Now you check your device, what it says, that it will say that CUDA is available, so it will select device as CUDA. That means now your model or your transformer will be using here GPU for the inference. Let's go ahead and use the tokenizer. So I write here tokenizer equal to auto tokenizer, and along with that we need to pass here model name, which model we are going to use. Earlier I told you we are going to use here GPT2 model. In fact, we will be using here GPT2 medium model. So we have here GPT2, we have Excel large and medium model. Let's go ahead and open these models and see their parameters. GPT2 large model have total 812 million parameter, whereas GPT2 medium model have 380 million parameter. So probably I'll go with the GPT2 large model. So I select here GPT2 large model. Alright, so in the GPT2 large model, if we provide here once upon a time, you should be getting here a better result. Previously we had seen there with GPT2 lowest model, so that was not giving us a good result. Now this should be giving us a good result. Once upon a time, Pizza Hut and Cheese Towns were all registered under Crispin Smith Electronics, a single state company that has now been merged with remaining Crispin Smith Electronics. Now you see there, this is a little, this is actually more coherent than what we had seen previously. So we'll be using here GPT2 large model. Then in tokenizer, we write here tokenizer equal to auto tokenizer. And thereafter I write here auto tokenizer dot from pre-trained, and in this I pass here model name. So it will download the tokenization method of GPT2 large model that will be stored in tokenizer. Along with that, we are going to download model, so that I write here auto model for causal language model, and there I write here from pre-trained, and then I write here model underscore name. So by default this model is downloaded on CPU, but once it is downloaded we need to shift it to our GPU for a faster inference. So I write here model equal to auto model for causal LM dot from pre-trained. Now you see there are many auto model for token classification, auto model for classification, auto model for causal LM, auto model for summarization. So there are many auto model. So this auto model for causal LM is used for text generation here. I provide here the checkpoint that's the GPT-2 large, and then it's going to download GPT-2 large here. It will take a while to download this. This may take some time because this is a large model. Okay, I'm just going to say that save the changes. It's going to save the changes. Alright, so 3.23 gigabyte. This is the model. This is quite huge model. If you are downloading it on your local computer, it may take a while to download, so you need to wait here. But on Google Colab, it download it really fast here. Once you have downloaded your model, now you can make here your input text context data. So I write here, I am really impressed, let's say. So this is my input context data. Now let's see here what this can generate for us. So I write here max length equal to the 128 words here. So this is the tokens, that many tokens we want to generate here. And then here I write here input IDs. As we know, in transformers, in previous videos, we have been, we have been discussing that in the transformers decoder and encoder, before your data goes, your transformers encoder and decoder, your data is tokenized before that, and then embedding is generated. So we need to do tokenization before we feed our data to our model. So I write here input ID is equal to tokenizer, and in this tokenizer we will be passing here input text data, and then I'll be writing here return PT. So in return PT I'll be in return tensor, actually not a PT. In return tensor I'll be writing here PT, that's the PyTorch. So it will be returning here a PyTorch tensor. Alright, now if you check these input IDs, as you know that these input IDs will be having input IDs attention mask here. So this has input IDs and attention mask. 1, 2, 3 and 4 tokens are there. You can see these 4 tokens, these are generated here. But we are interested to take only input IDs. So I write here input IDs. That input IDs I'm going to write here. Input IDs equal to input IDs, and then I write here this particular key. Now we have already shifted our model to GPU. We need to also shift our tokenizer to GPU so that it can perform faster. Now this input IDs will be having only these tensors there. Alright. Okay, seems like something is wrong. Okay, so before getting that, we had actually, just a second, let me see, somewhere we made a mistake. Okay, wait. Okay, so the problem is here actually, this should be as a string here. Alright, so input IDs goes to GPU. Once you have your input IDs to GPU, now your model is ready to generate the text data. As I told you earlier that we will be using here beam and nucleus sampling technique. So in beam sampling technique, once you call your model dot generate here, alright, so it takes here input IDs, max length and the number of beams here. So there are many options here. So depending on which model we have downloaded, it takes those input parameters. So basically you can search here this causal language model which you have here. If you search this auto model causal language here, alright, auto auto model for casual language that you can see in fact in, let me show you, that you can see here in the task. Then you come to there as text generation probably. Instead that you can go into the docs and then you search here auto model for the causal language model. You need to click on here. Thereafter you will see there this particular the transformer class we are using here. All right, so this class we are using, it has various methods here. All right, these are the input parameter which it takes there, and then you can apply these. You need to go through these documentation, then you will be able to see all the techniques which is used here. So basically we write here model dot generate, and then I write here input IDs. Thereafter I write here max length equal to max length, which we had defined earlier. This we have defined earlier, which is 128. And then I define here number of beams equal to 5. So number of beams means there would be a 5 branches in each of these, after each of the predictions. So there will be 5 branches if I say number of beam equal to 5. Once all these things are done, then I say here do underscore sample equal to false. So if I say do sample equal to false, that means it's going to use here beam search without any top case sampling. Thereafter I write here the output is like this, and then I just run this. If you check this your output here, if you check your output, you would be able to see there kind of the encoded text encoded data like we had seen for input IDs here. So these are the encoded data. Now we need to convert back these encoded data into, these encoded data should be converted into a text data. So for that you need to use again here a tokenizer. So the tokenizer dot decode, and then you pass your output. All right, since this is multi-dictionary, this is a multi-label of the list, so we need to select this particular list that I select with 0, and then you need to just run this. Now if I run this, what I would see here, these will get converted into here a data, into a text data. If I print it here, so this new line will be printed there properly. So it says that I am really impressed with the quality of product and customer service. Seems like very coherent text data. Rated 5 out of 5 by anonymous from great product. I have been using this product for over a year now, and I have never had a problem with it. I have been using this product for over a year now. Now this is a problem here. What do you see here? We can see here these text data are being repeated. All right, that's the problem we had seen earlier, if you remember. These are the problem here, repetition. So these repetition we need to avoid here. So to avoid these repetition, what we need to do here, we need to introduce here a penalty for these repetition. So for these repeat, once we introduce a penalty, it will then not repeat the text data. All right, so for the penalty, I'm gonna just write here that no repeat. Now you check it here. It says that no repeat underscore. Thereafter, I need to write here no repeat ngram underscore size equal to 2. So no repeat ngram size equal to 2. Now what we see it here, we need to just run it, then we would be able to see its output. Now you should be able to see it here. If I remove this print, in fact, I would be able to see it here itself. So as soon as I removed that print, I can see it here. I'm really impressed with the quality of product and the customer service. Rated 5 out of 5, anonymous from great product. I have been using this product for over a year now. I'm very pleased with it. It is very easy to use and works great. I would recommend it anyone who is looking for product that will last a long time. Now you see, all the repetition is gone here. Alright. So that's how these beam search works. But problem with the beam search is, if you run it multiple times, the probability is that you are going to see here almost same type of the text data every time. Alright, now you see this is the same type of the text data every time. So this is the serious problem with the beam search. Now we are going to see how you can do nucleus search. So for nucleus search, we will be using here those technique which we had discussed earlier, that the technique was that the top P. So we'll be deciding there some probability. Based on that probability, we will be selecting the samples. All right. So it's again a very simple process to select this. You need to just write this kind of the same code you can take from here itself, and then you just write it here, and then I'm going to write here output equal to model dot generate input IDs. Then I provide here a max length. These number of beams is not needed now, and these do sample would be true now because this would be a sample method. So this do sample equal to the true, and thereafter I need to select here top P equal to 0.9. So this 0.9 is like the probability percentile from where these most probable tokens will be selected, and thereafter sampling will be done on that here. Alright, let's go ahead and run this. Now you should be able to see here, the different text data every time we generate. So I'm really impressed with my gift. The first thing that popped up in my mind when I saw it was, wow, this is cool piece of art here. If I run it again, now you should be able to see it here, a different text data. I'm really impressed by how fast it was for price. I'm glad that it works, etc, etc, etc. Now that's the beauty here. So what's the purpose of this top P? Suppose that if I select it here 0.1, that means we are taking every tokens which are above 10 percentile, means we are taking here a huge amount of tokens for random sampling. Now if we run it with lower top P, our coherency of the text data would be quite low. Now you see, I'm really impressed with the quality of the product. I have been using it for a few months now. I'm very pleased with the result. I have been using it for a few months now. I'm very pleased with the result, etc, etc, etc. Now this is not coherent here. That's the problem with if you select a lesser top P. And if you select it here, a very high top P, let's say 0.999, something like this, then in this case what will happen, you will be selecting here a very small dictionary. So if you run it multiple times, the chances would be there you would be getting very less variation in a multiple generation. Now this time you see here, I'm really impressed at the overall performance so far. Let's say if I again run it, then you might get a different result, but the chances are here that probably you might get the data which are aligned with what you had seen previously. Alright, although there is no guarantee, but if you select it here 1, let's go ahead and check it with top P equal to 1. That means it's going to select there the best one here. Alright, so I'm really impressed with them. Now I would like to thank you sincerely for sending me such great cert, etc, etc. Alright, if I run it again, now we are going to just check that if it is going to change the text data or not. Now seems like it has changed the text data. Now you select the top P equal to 1. In this case, it will be highly factual. And if you want a little bit more variation in your text data, you can lower your top P probability here. And if you want to generate it for some other input IDs, you can simply, take all these from here and then paste all these here again. We have got input IDs. Thereafter, these input IDs, we put it here. Something like this. Now I'm gonna change it here. So let's say I write here, welcome to KGP Talkie tutorials. Alright, let's go ahead and generate this text data, what we are going to see here. Well, so it says that where we will talk about the new tools of your iPhone, etc, etc. Although I don't talk about this. Welcome to KGP Talkie tutorials. We will talk about machine learning. Now let's go ahead and generate the data and then see it should be generating a coherent story here. So it says that talk about machine learning with Python and some common question we got asked from the blog. This tutorial is going to cover most popular machine learning methods, etc, etc. Now you see, you can, nowadays ChatGPT has came into the market, but if you can make your own model somehow and that can generate your own data, it would be like ice on cake there. So this is how you can generate text data using GPT-2 model for your own purpose. We have covered here various techniques which are used in generating the text data. Please do like this video and share it with your friends on social media and subscribe this channel. Thank you so much for watching this.